Stuff, please. All right. Okay, so what are we going to do here? We want to
Split it.
Split it in half.
Okay, good. So first what we want to try, before we do anything else, we want to try to factor out a greatest common factor. But remember, the greatest common factor has to be a factor of all of the terms, not just some of them, right? So we couldn't say, for example, that maybe I have a number that works on 3 of them, but it doesn't work. It's got to be a factor of all the terms. So there isn't one, is there? There's no number that we got a 1 there, right? The coefficient are -1. And so already we know that there's no way we're going to be able to factor a number out of everything, right? Is there a power of x? No, there's not, because that 9 doesn't even have an x, right? So I can't factor any power of x out either. So we just tried, but there was nothing to factor out. Now we group. Okay, I'm going to show you, I think there's a couple things here maybe we can add to the process that might make this a little better for you. So we're going to split it into groups, right? Now
Divide
before,
by x squared.
say it again.
Divide by x squared removed.
X squared. Okay, we're going to factor out an x squared. Before we even go any further, though, let's just kind of look at the type of pattern we're going to get out of this, because we can actually get most of the way through this problem without doing any math. We can predict what's going to happen, right? We know that from the left group, we're going to get a greatest common factor and a leftover, right? Plus, in the right group, we're going to get, I'll use a little different color of blue, we're going to get a slightly different greatest common factor. But what's going to happen? What about the leftover?
It should be the same.
It's going to be the same. If this is going to work, that leftover needs to be the same, right? And so if it's the same, then our next step is going to be whatever our leftover factor is, it's going to be a factor of each of these 2 terms. So we're going to go ahead and pull that one out front, meaning we're going to factor it out. We're going to divide it away from everything, and we'll just put it in front. So there it is. And what are we going to be left with? Well, when those are gone, right, when the greatest common factors have been undistributed, we're left with whatever that was, the GCF of the first group plus the GCF of the second group, right? And then we factored by grouping. Dalton, please turn that off, put that away. Use it off. Okay. So we're done grouping, and then maybe we can go further, but that's going to be a different strategy, right? Grouping did its job. We took this 4-term polynomial and we broke it down into a product of 2 smaller ones, and then we can see what we can do with those. Maybe we're done, maybe we've got more to do, right? So now let's fill in the blanks. And I just assumed it was going to work, and it's going to work. I mean, the assignment I give you, it's going to work. I mean, these are designed to practice factoring by grouping, but it wouldn't always work, right? So the greatest common factor of the first group was what?
X squared.
X squared. Okay, good. So that's the biggest thing I can factor out of the first group. Let's see what that gives us. So I'm just going to divide each term in the first group by x squared to see what remains. Right? Now here's where some people had some issues. This came up a lot. I understand why it would. So 4x cubed divided by x squared, what's that?
4x.
4x, right? X cubed over x squared is x, and I've got a 4 there, so I get 4x. Here's where people had trouble. X squared divided by x squared,
Which is x.
it's not x. What is it? It's 1. They cancel, but they don't cancel to 0, right? There's a difference. When we cancel stuff in math, there are different kinds of canceling. Let me illustrate that. Like if we do something like, let's say we've got something like 3x squared plus 2x minus 4 minus 2x plus 3x over x. Okay, there's what I call what you might call horizontal canceling and vertical canceling. 2x minus 2x cancels, doesn't it? What do those cancel to? What do they add to? 0, right? So those truly do, those go away, right? They cancel and they're gone completely. But when I cancel something vertically, it doesn't go to 0. When I cancel these x's, what am I really doing? I'm not making it into a 0 because 3 times 0 would be 0 and that term would disappear, but it doesn't. The 3 stays there. So x divided by x, and this isn't anything super profound, you know it. What is anything divided by itself? 1, right? So they cancel to 1, right? That's a vertical canceling. And so in this problem, this is a case of vertical cancellation, isn't it? When we cancel the x squared over the x squared, it doesn't go to 0, it goes to 1, right? That make sense? Now here's what I recommend you do. As you're going through this process, let's just redistribute to check ourselves. That's all you got to do. So we'll take the x squared and we'll distribute it now. That's our GCF. Let's distribute it to both terms and see if it checks out. Is x squared times 4x, 4x cubed?
Mhm.
Check, it is. Is x squared times negative x squared? Yeah, right? So we did the first group correctly because when we reversed the process, we were right back where we started, right? So we did it correctly, okay? Second group. Now what about over here? We can be a little bit smart about this, right? We don't have to go through the hard, I mean, in this case, it's not such a big deal, but we don't have to reinvent the wheel each time and figure out what the greatest common factor is because we know if this is going to work, what has to be the same between the first and the second group? The leftover, right? So let's just assume that it does work, right? And we're going to put that leftover, make it the same, and then we've just got to ask ourselves, okay, what would I need to make that work? Negative 36x times what? Or excuse me, what times 4x would give me negative 36x? Negative 9. Okay, and there is a way to get that too, by the way. I know that when I distribute this, negative 9 times 4x is negative 36x, right? That product equals 36. So if I really wanted to know what went there, I could just say negative 36x divided by 4x is equal to what? Well, negative 9, right? So I could figure it out that way if I wanted to. I could always just divide that first term in the second group by the first term here to figure out what that number would have to be, right? Now let's check it. If we redistribute the negative 9 times 4x, is that negative 36x?
Yes.
It is. Check. Is negative 9 times negative 1 positive 9? Yeah. So we know we did it correctly. We know that we factored everything correctly. So now we just keep going, right? What goes here?
4x minus 1.
4x minus 1. Because that's the common factor. That's the one that's the same. That's the factor that's the same in both groups. So we can factor that out or distribute it. What's left behind if I do that?
Squared of
X squared plus negative 9 is what's left behind, right? And so we end up with x squared plus negative 9, and then we could rewrite that in a little easier form. We can just make that x squared minus 9, right? So we get 4x minus 1 times x squared minus 9. Good. Factoring by grouping did its job. So we broke this thing down, we split it apart from one big factor into two much smaller ones. This one's done, for sure, because the x is not being squared. This one may or may not be done. Could I go further with this factor? I can. It's two terms,
Oh.
and so if it's gonna go further, I just have to see if it's gonna match one of my patterns, right? Which pattern does that match?
X, or a squared minus b squared.
Yeah, it matches a difference of squares, right? So could we write this then? We just want to be able to write this as something squared minus something else squared. Well, what is 9?
3.
Yeah, it's 3 squared, right? So x is like my a and 3 is like my b, and I'm just going to split that apart by using that pattern. Okay, well, what's my pattern again? And you just kind of have to know those patterns. A squared minus b squared, how does that break down?
A minus b.
A minus b times
A squared.
a plus b. And
Oh.
this is the one that's the easy one, right? The cube's the one where you got a small factor and a big factor. Okay, so, and you can put those in any order, right? So this is just going to break apart then into instead of a minus b, it's gonna be x minus 3, right? Instead of a plus b, it's x plus 3. Okay? Make sense? Okay. Let's try one more of those.
You just said that we had one.
Yeah, you can, but let's just do one where we have to factor something out, and then I'll let you go. Okay. Yeah, we should just do this quickly. So, what do I do on this one first?
See if anything goes into it.
No.
See if anything goes into it.
Five.
Something does. 5 does, right? So if I undistribute a 5, I'm going to get 5 times. I'm going to put brackets out here. Because the brackets mean there's a lot of stuff going on in there, maybe, right? So we got 5 times, what's that going to give us? 20 x cubed plus 25 x squared plus, what's that going to be? 24 plus 30. Okay, make sense? So we've got that factored out the 5, made the numbers smaller, that's good. Now we'll split this down the middle, right, into 2 groups. So what about the first group? What's the greatest common factor of the first group? 5 x squared, good. And what's going to be left over then? 20x cubed divided by 5x squared is what? 4x, good. 25x squared divided by 5x squared? 5.
What are you dividing by? 4?
I'm dividing by 5x squared.
Oh, good.
Right, in both cases, I'm just dividing this by 5x squared. Okay, and then on the other side, we know that we're going to have the same leftover, right, if it's going to work. So what's my leftover going to have to be? What times 4x is 24x? 6. Okay, let's check all this stuff. 5x squared times 4x, 20x cubed. Yeah, check. 5x squared times 5, 25x squared, right? 6 times 4x, 24x. 6 times 5, 30, right? So now what? Casey, what's my next step going to be here then? What am I going to factor out of both terms? You can tell me.
4x plus 5.
4x plus 5, right? That's my greatest common factor, so I'll factor out 4x plus 5, and what's going to be left behind?
Plus.
Good, 5x squared plus 6. Right, and don't forget out front, what's out front?
5x squared.
Remember, I've still got, out front I've got that 5, right? So, there it is. I've got 5 times 4x plus 5 times 5x squared plus 6. So am I done? This time I am. Because look at this other, so the 4x plus 5 is done, the 5 is done. What about this one? Well, if it matched anything, it would be a sum of squares, and that's not a pattern, right? And furthermore, there is nothing that squared becomes 5x squared, right? 5's not a perfect square, and nor is 6. So we'd be done there. We couldn't go any further, right?
Yeah.
Does that make sense? Okay. I'll go get Chromebooks.
Thank you.
What I want you to do, even if you're not up to this point,